Good day to you. This is again your Professor Dr. Benjamin Cabrera, and we'll be discussing today for those who are my students in the PSWD, we will be discussing the principles of immune system and disease transmission. Okay, let's begin. Okay, so the objective of this lecture is to review the immune system and its arms, understand basic principles in immunity, to understand principles in disease transmission, and correlate it to clinical settings. So what is immunity? So we define immunity. So there are different definitions. So we can Google it up, and there's so many definitions. And this is my first definition came from Sherry's Medical Microbiology. Immunity is defined as a complex and precisely regulated inducible defense mechanism that allows the specific discrimination between self and non-self. So what is important here is the complex and precisely regulated, and it should be inducible. You stimulate it, okay, and it's a defense mechanism that allows specific discrimination. So we should know what is ours or the self and what is not ours, which is non-self. Then another definition would be uh, from Jowett's Medical Microbiology, which is the 24th edition. Immunity is defined as the development of resistance, that is immunity, to a foreign substance, which is your infectious agent. It can be an antibody-mediated or humoral, cell-mediated, or cellular, or both. So now let's talk about the two arms of your immune system. So we have the two arms of your immune system, your innate and adaptive. So let's talk about your innate immune system. So your innate immune system, meaning innate, it is we are born with it. So these are your anatomic or physical, even your physiologic, your reactions, your normal reactions, the phagocytic and inflammatory events that happens inside your body. And your innate immune system is present intrinsically, meaning within ourselves, but this type of immune system offers no memory. It's just there, it reacts, it protects us, and it has limited diversity. The next would be your adaptive immune system, another arm. The adaptive immune system comprises the main layers of your adaptive immune system would be your T and B lymphocytes, and of course with the presence of an antigen presenting cell. So your adaptive immune system as compared to your innate immune system, your adaptive immune system is inducible. You have to stimulate it. It is very specific. It doesn't react to anything. Just you need a certain antigen for it to be stimulated. And it does have a memory. It, it can remember, and it has the extensive diversity, and this one really will determine or differentiate the self from non-self. And of course, with all good process, there should always be self-limiting. Imagine why make it self-limiting? Imagine if it's not self-limiting and you continue reacting and reacting even without the presence of the antigen, that would give us a lot of problems. So here is a very good table that differentiates your innate and adaptive immune system. So as the characteristics, as the specificity, your innate immune system has structure. It's not specific because it has a structure shared by groups of microbes. While your adaptive, there is a specificity There is for the specific antigens for the microbial and non-microbial agents. Diversity. Your innate has limited diversity as compared to your adaptive, which has high diversity. As to memory, your innate doesn't remember, but with your adaptive, it does remember. Self-reactivity, both should not uh, possess the characteristic of self-reactive. They should not react on themselves. Okay. So what are the components? So anatomic and chemical barrier for your innate. These are your innate immune system. Your skin, which is it covers our body externally. Your mucosa that covers internally. The chemicals in our blood, like your lysozymes in white cells, your interferon alpha and beta, even the temperature is a type of defense mechanism. Your fever, sometimes we control fever for the processes that it brings forth, but actually it is a type of defense mechanism of the innate type. And the pH especially are the pH of our stomach, the pH of our urine, the pH of the certain part of our gastrointestinal tract. It all protects us from foreign organisms and foreign chemicals or objects. While your adaptive immune system, your anatomic chemical barrier, it comprises of the lymph nodes, the spleen, the mucosa-associated lymphoid tissues. Okay, so those are the anatomic and parts of your adaptive immune system. How about for the blood proteins? So the blood proteins are differentiated into innate and adaptive. For innate, your blood proteins will be comprising your complement. Where your adaptive, it will be your antibodies. For the cells, the cells involved in the innate immune system are your phagocytic and natural killer cells. And for your adaptive, it will be your lymphocytes. So these are your lymphocytes, which are cells other than your NK cells. So in your innate and adaptive immune systems, antibodies and complement enhance phagocytosis. Antibodies activate complement, while cytokines stimulate adaptive innate processes. And innate and adaptive arms interact and augment each other. They do not work alone. They may work alone for a while, but later on, generally, they work um, simultaneously and they help each other. They interact and augment each other through soluble substances like your antibodies, your complement, and your cytokines. So this is also a very beautiful representation of how we divide our immune system into two parts, your adaptive immune system and your innate. So you see your adaptive immune system, your innate immune system first would be the one that we are born with, where we are blood and your physical barriers. For your blood, there is your complement. It involves your complement cascades and it stimulates the alternate pathway. And with the blood, there are your phagocytes, your white blood cells, your neutrophils, your macrophages, which are your mature monocytes, your basophils, your eosinophils, and natural killer cells. So all of these cells will bring about the death of dangerous organisms. For the physical barriers, it will be your skin, mucous membrane, saliva, the flushing action of your urine and tears, and stomach acid. So with these physical barriers, they stop infection before it enters the body. So while on the adaptive arm of your immune system, it has your T cell and your B cell. So remember, that's all the two important cells, your T cell immunity and your B cell immunity. Your T cell is involved with your cell mediated. So remember, T cell is cell mediated. Okay. While your B cell, it's humoral. It's the production of your antibodies. Okay. It's humoral. Okay. So with your T cell immunity or your cell mediated immunity, your whole T cell is released into, okay, they differentiate into suppressor T cell, your helper T cell, and your cytotoxic T cells. And all of these T cells will bring about the death of the body cell. Remember, it is the body cells that are infected with the virus or otherwise damaged. So it is also involved in the regulations of the health of our cells. Those cells that are not healthy are killed or destroyed by your suppressor, T helper, and your cytotoxic T cells. On the other side will be your B cell immunity, your humoral immunity. With the antigen exposure, it will stimulate your lymphoblast. Then your lymphoblast will divide, differentiate into your plasma cells and your clonal B cells. Your clonal B cells will turn later on be your memory B cells. Okay. All your plasma cells will produce your antibodies and still goes to your complement cascade into the classical pathway. So this one, in this, your B cell immunity is the one that cross over or augment your innate immunity. So your classical pathway and alternate pathway will meet, and later on it will stimulate the following. It can stimulate your uh, white blood cells, ending up to the death of the organism or direct killing of the bacteria. So remember this beautiful slide because it almost summarizes our immune system. So yeah, I'll now be talking about the principles of disease transmission, how we are able to get disease. So what are the processes that are involved before the production of an illness? First, there should be an exposure. So exposure, instance that a person or animal is being exposed to a disease or pathogen, just exposed, like someone sneezes at you, or you may be able to take hold of an infected fomite or material or a surface, or you being pricked by a needle or exposed sexually. So that's initially that will be your exposure, followed by the infection. Once the organism will be able to go through and be able to bypass our innate um, protection, they tend to multiply, okay, within the body. Still, there is no infection. No, there is no manifestation of the infection. It's just there will be multiplication of the infectious agent. And the process before symptoms will appear will be the incubation process. It's the development of a disease from infection until the signs and symptoms appear. Okay, so that is your incubation period. And later on, the process of the production of the disease, which is defined as an abnormal condition of a part or organ resulting from an infection. So resulting from an infection. So there are instances that a person or animal will be infected but will not manifest the disease. They are called your carriers. So these your carriers are persons or animals with asymptomatic infection that can transmit the, the infection to another susceptible human or animal. Okay, continue the definitions. So we have the term invasion, which is the process whereby a bacteria or an animal parasite or even a fungi and viruses enter the host cells or tissues and invades and it spread in the body. So that is your invasion. Next would be your pathogenicity. When you say it's pathogenic, so pathogenicity is the characteristic or ability of an infectious agent to cause disease. That's it. That's your pathogenicity. The capacity of an infectious agent to cause disease. And toxigenicity is the ability of a molecule to produce toxin that will give the development of the disease. And virulence is the quantitative, the word is here is the quantitative ability of an agent to cause disease. So it's almost synonymous with your pathogenicity, but your pathogenicity is just the ability. It is qualitative, ability of an infectious to cause a disease. But virulence says it's a quantity, how much of the organism or an agent will be able to cause the disease. So it is just numbers, quantitative. So a pathogenic organism causes or is capable of causing a disease, and some pathogens cause disease only under certain conditions. Okay. Wow. Oh, hi. There are instances that they will be introduced into a sterile body site or infection and immunocompromised cells. Why? How can you explain this one? Because do you agree that we are more of a bacterial colony rather than humans? Because the number of bacteria outnumbers our human cells. So we really are walking colonies of bacteria. But these bacteria, which will reside in certain parts of our body, are called our normal flora. Especially there is a diverse normal flora types of bacteria in our gut. There are microbiota. So uh, there are bacteria in our skin, the nose, in the mucosa, in our intestines, okay, in every part of the body, so that there will be certain organisms that are allowed to reside and they will not give any problem. And actually, they are protective because that is their home, and they should protect their home from other bacteria that are not locals. Okay, so for those who are foreigners. So whenever a certain normal flora of a certain part of the body will be introduced to another part of the body, example would be a ruptured intestine. This ruptured intestine with all its intestinal content in the bacteria will be uh, uh, go will be uh, spread to the peritoneum, which is not a part of the intestinal mucosa. It will invade now. The organisms from our feces, from intestinal mucosa will invade now, will be uh, uh, transported to the peritoneum, and they will multiply and cause problem, causing peritonitis. And even later on, they can invade the bloodstream and will cause sepsis. Okay, or that would be in a immunocompetent host, but it will be another story if you have an immunocompromised host. Okay, immunocompromised meaning your immune system is very weak that it cannot protect ourselves. So even those who are normal residents of a certain organ, these residents are usually checked, their numbers are checked by our immune systems. So if our immune system are sick and are weak, there will be overgrowth of of bacteria in a certain locality, certain part of our body, and this can cause invasion and uncontrolled multiplication, later on bringing forth illnesses. Okay. So, infectious processes have different stages. First, there should be entry into the host, okay, with evasion of your primary host defenses or your innate immunity, followed by adhesions of the microorganism to the host cells. Okay? And then should be propagation of the organism or multiplication within the host cells. And later on, the host cell will be uh, uh, overwhelmed, and it causes damage to the host cells by both the bacterial toxins and or inflammatory response of the host. And lastly is the evasion of your host secondary defenses or your adaptive immune system. So another word to remember is your virulence factor. So remember that virulence is the quantitative amount of the organism to cause a disease. Your virulence factor, okay, will be depending on the following processes. First, entry the host cell organism must be able to overcome the host defense. Virulence factor. In the respiratory tract, in the gastrointestinal tract, in the urogenital tract, okay, they should uh, they should be able to overcome the host defense, and even in the skin, okay. An example of your virulence factor that aids a certain organism to bring forth problems would be the presence of your polysaccharide capsules. Okay. They can evade host defenses in these organs or in these tracts. Your polysaccharides like your strep pneumoniae and your Neisseria meningitis. Then, after the entry, there should be adhesions of their microorganism to the host cells. These adhesions there are certain bacteria that has additional structures that promote adhesions, like your E. coli, your Escherichia coli has pili that enhances adhesion to the intestinal mucosal cells. Your group A streptococci has fimbriae, so these are also like pili, smaller pili, that also will help attach to the respiratory tree, the respiratory mucosa. And then, after the adhesion, there should be invasiveness. That's one of those are the virulence factor. Invasiveness, because there are certain bacteria that will produce enzymes that later on break down structures in the tissues and even of the host. So these enzymes like your collagenase and your hyaluronidase. So these enzymes degrade components of your extracellular matrix. So invasiveness, virulence factor, adhesion. Next would be the production of your bacterial toxins. Some bacteria cause disease by producing toxins, especially your your gram-positive that can produce exotoxins, but also your gram-negative. Okay, so for exotoxin, these are produced by your gram-positive and your gram-negative. And it's as little as 1 microgram of tetanus exotoxin can kill an adult human. You see how powerful it is. So your exotoxin, your tetanus is an exotoxin, your tetanus is a gram-positive bacteria. Then your endotoxin. Your endotoxin are specifically produced by your lipopolysaccharides. They are not secreted. Rather, they are integral component of the cell wall of your gram-negative bacteria. So, so your endotoxins are only produced in your gram-negative. They are not secreted or excreted. Rather, no, yeah, they are not secreted. Rather, when a bacterial cell wall will be degraded, it can now excrete or release the endotoxin. So endotoxins are only found among the gram-negative bacteria. When these are released into the host circulation, following a bacterial cell lysis. So when you destroy a bacteria, either mechanically, chemically, or even through our phagocytes, they can now release out the endotoxins, or gram-negative, causing fever, shock, hypotension, and thrombosis. So you now have your septic shock. So septic shock is usually are produced by your gram-negative bacteria through their endotoxin. So viral pathogenesis at the cellular level, cell death. Okay, a cell can be directly killed by the virus. Death, dead or dying cells release progeny viruses. So once a cell is been infected, then there's invasion of the virus. It can directly kill the cell and multiply within the cell before it kills them. They will be released, okay, in the system, and again infect and invade other cells, and the process continues. Example of this would be your and your poliovirus. So it causes direct cell death. And a virus can also transform, other than killing the cell, they can transform the cell into malignant cells. So they transform a formerly normal cells. They tweak it into forming into a malignant type of cell. Or they can induce cell fusion, so cell death, transformation, and cell fusion, wherein your infection of cells with certain viruses causes the cell to fuse, producing giant cells or multinucleated giant cells. Example of this would be your herpes and your paramyxoviruses. Or the fourth, they can be cytopathic effect, okay, or your CPE, any visible change in the appearance of an infected cell. Example, there will be rounding or production of patches of stainable viral protein inside the cell, and later on leads to cell disintegration, either by mechanical means, like your RBC will not be able to pass through your spleen and they will be destroyed, or they will be detected by killer cells, or, or, or white blood cells, and they will be killed by our white blood cells. Okay, so that ends my lecture. I think this is part one of two lectures. Okay, so I just discussed the principles of disease transmission and principles of immunity. Okay, and I hope you learned something out of this lecture, and keep on learning, keep on believing that you will learn and become good doctors in the future. And that I thank you. Anyways, before we end, please don't forget to subscribe, okay? Click your thumbs up and click your notification and subscribe to my channel so that whenever, especially if you are my student, whenever I'll be making new lectures, you'll be the first to know it. Okay, bye bye.